Let's take a look now at equilibrium. So when we have a reaction that has an equilibrium, it means the reaction can go in two directions. We can go forward, so we can go from reactants to products, and then we can actually go back in the other direction, and our products can interact, and we can reform our reform our reactants. When we're at equilibrium, there's a certain ratio of products to reactants that any given reaction wants to be at. And so it tries to maintain that status quo. Now, equilibrium doesn't mean that everything's present in equal amounts. Okay, so if I have a reversible reaction, it's one that can occur in both the forward and the reverse direction. So again, I can form my products. My products can then reform reactants. Something that's irreversible only proceeds in that forward direction. It can't go back in the other one. All right, so at equilibrium, again, it's not that I have equal amounts of everything. What is at equilibrium is the rate of the forward reaction is equal to the rate of the reverse reaction. And again, every single reaction is going to have its own unique ratio of the products to the reactants that it wants to hold. Some reactions are going to heavily favor the products. Other reactions are actually not going to proceed very far and heavily favor the reactants. Whereas there are some reactions that do get a pretty decent mixing of both. Okay, so we get to equilibrium when the concentrations are constant and the rate that we're forming products equals the rate that we're reforming reactants. Okay, and so we're not changing the concentration any longer with time. Every time I make a product, I reform a reactant. Make a product, reactant, product, reactant. Okay, so the rate that this is happening is equal to the rate that this is happening. All right, and so in this particular reaction, we have reversibility here. So we've got this double-headed arrow. When I type it, I end up typing it like is shown here. When I draw it, I draw them like this, okay, to show that it's reversible. And so here I've got a colorless gas that converts to a brown gas. And at equilibrium, I have a mixture of both my original colorless reactant and my product. And so some of my product molecules will collide with each other and reform reactant. When that happens, to maintain the ratio, then some more reactant will break down and form product. When you have a reversible reaction, you can start with either reactants or products, and you will get to equilibrium no matter what. So in the first picture A, I have started with all reactant and no product. Eventually, I reach my equilibrium. In the other picture, I start with all the product, the nitrogen dioxide, and eventually I form back enough reactant that now I've reached that equilibrium between the two. Okay. And here's just another picture. Again, our concentrations will change with time until we get to that equilibrium point where the rate of the forward reaction equals the rate of the reverse. So again, it's not equal amounts of everything, it's an equal rate. The rate of the forward equals the rate of the reverse.